I started the recorder, therefore now it is a good time to once more start the lesson, programming technologies. The lecture is about the graphical data. It is lecture number 7. It is the last lecture in the series, in these classes. And in the topics, uh, we have the word terms data. Therefore, let's start to answer the question what the data is. What is the data? I will try to answer this, but first, precise, detailed, more details about the agenda. We will talk about the graphical data, but we start talking about the delegates and events. Next, we'll talk about XAML, expandable application markup language, and talk about the view model pattern. That you are familiar with all of the topics, but I think we could summarize and analyze in the context of the code, example code, the details about all of that. Not all details about these topics was covered by the project and by task. So it is first question. Uh, Let me ask you next question. I mean, it's all of this question. It is good opportunity for you to get additional points for your activity during the lecture. Let me recall you that answer to this question. I'm trying to assess your answers, but to get activity point is not required to precisely answer the question. It's enough to point the good direction where we try to find this the answer. But during the test, of course, you must provide uh, answer, detailed answers. Let me recall that we are talking about program, so we are talking about the text, and the text is usually organized in layers. We talk about the presentation layer, about the business logic, and about the data. Today we will talk about the presentation layer. MVVM, it is a pattern that comes from the technology related to the presentation. I will discuss it in more details. But this model, as you remember, actually the program usually get access to the external data. And we can organize the external data using graphical user interface, using databases, and using file. During this lecture, today we'll discuss graphical data, but previously we discussed structured data. We also discussed streams of data. To discuss structured data, we need some basic knowledge about the functional programming. And at the very beginning, we started discuss about the data semantics. So it is more or less the scope of these classes. Today we'll discuss about the graphical data, but I'm recalling it because all of these points, all of these topics will be required during the test. So I think that there's enough time for you to answer the question if the information is abstract. Of course, it is abstract. It is abstract. Therefore, next question I have, is it possible to process directly? The most important thing is directly information using computers. Uh, what it means that the information is abstract? Of course, it's abstract because it is something like knowledge. and it is impossible. The knowledge must be represented as the data to get physical representation, to get to use physical physics to to organize, to construct, to design any machine that could be able to process something. It could be physical. So all of you answered that it is impossible. Yes, it is impossible because data is abstract. But now let me ask you a question. It's also the question from the previous lectures. What is the data streams? What is data streams? Uh, but here you have actually my last message. But let me get back to this message of these classes at the end of this lecture. Because from this picture you can learn that we are talking about the graphical data, we are using about the streams, and we are talking about the structured data. Therefore, it is very important for us what how it relates to the technology, how to use technology to get access to manage all the kinds of the data. But first on the list, it is delegates and events. But to start discussion about the delegates and events and answer the last question related to the previous discussion, what is a language? We talk about the programming language, we talk about the languages that we are using to represent information and to create data. If it's only the data, it is not related to behavior of devices, of something. We can call this language as a code, as coding. Sometimes we are using coding to represent the information. But now the question is what the language in general is. We'll get back to this term at the very beginning during today's project lessons. We discuss about simplicity of the questions. As you know, I am also asking about. I am only asking very simple questions. The problem is that simplicity. It's very difficult to measure the simplicity. Okay. So the rest of this lecture, I try to discuss in context of our example code. Therefore, let me open the Visual Studio, and in the Visual Studio, I have example external data management. It is solution that calls X data management. And first, delegates. Let me recall what the delegates is. The example of delegates we have in the class delegate example, and in class delegate example unit test. But first, it is delegate. And first question for you is, what kind of delegates? I'm pretty sure that we discussed it previously, but let's get back to this topic. What kind of delegates you know in terms of the language? What kind of delegates? Let me recall that we discussed only two words. It is required here because we have two delegates, and the example of this delegate you can find on the screen. I'm waiting for your answers. Okay, so there is no one that tried to answer this question. Only one answer I have. Not. You are trying to generic single. No. Uh, as I said on the screen, there's examples here we can find a word delegate, and this word delegate, it is coupled together with this definition, and from this we can learn that delegate, it is okay. Let's stop discussion now, because what is the role of an event in terms of the language? But let's get back to the delegate. From the line 21, you can see the delegate actually is a type. So the first kind of delegates, it is type. The type, as you remember, it is a collection of values and operation we can apply against these values. In this case, all the values are references to the method. Here we are defining type, so we are expecting there is many values possible. So we can say that in this case it is all of the references that can refer to the methods with this signature. Actually, here we have signature, integer. This identifier, it is name of the type, but here you can see the list of parameters. It is first kind. Second kind, you can see in the line 27. In the 27 line, perform calculation. It is, as the name says, it is variable. It is variable of the type, it is of type delegate, but usually we also call it delegate. Therefore, it is second kind of delegates. It's variable types and variables. Of course, during the runtime, we can also talk about the third kind of delegates. It is an object that refers to the method. And the method, the description of the behavior, description of the set of statement that must be that should be executed after calling the method. So we can talking about the delegate, we are talking about the calling a method, and we are calling about the references that points out to a method. It's very important for us. But next was what is the question related? What is the question related to the event? As you can see, event here, it is the role of the event is also variable. It is also variable, and this variable, it is the name of the variable, has type. Of course, the type must be delegate. Big definition. From here, we can see that in this case, we are also talking about the delegate. So we have type that it's delegate type. And in this case, we are talking about all of the method that don't provide any return value and has two parameters. One that is an object type, and second is event args. Usually we are talking, but it's just a name. We are talking about method with similar signature. We are talking this method as handlers, because we are using handlers to handle an event. So actually, getting back to the delegate, here we have variable of delegate type. This type provides a few operation, and here you can see the operation. We can assign the value, so it's assigning a pointer. It's not pointer in this language. We are calling it reference to a method, and we can create, for example, this way, creating using the name of the type, and as a parameter providing the name of the variable. In this case, perform some. It is the method that it's defined over here in the 41 line. but it is one operation. It's assigning to. Second operation that we have with delegates is calling all of the methods, because the delegate is a collection. Is a collection of the references, not just a value. So it is possible not only to assign new value. In this case, we are assigning new value, but we can also add new reference to this value because it's collection. So we have operation add, and because this type and this concept, this idea is embedded in the language, uh, the operations are available as operation in the language. But today it is not very important. More examples about how to use delegates you can find in delegate example unit test. Here, there's more examples. You can, for example, here can see how to add a new item to this collection. Perform calculation variable is a collection. So if you are calling here, it is an example how to call all of the methods that was assigned previously, has been assigned to the variable. So are part of the collection. We are using typical scenario. We are using typical syntax as a method call. In this case, it is member method call, because perform calculation method, it is delegate that is a member of delegate example type. Here we have a name of the variable that provides reference to the object. So it is the first point we discussed during the project many times, the term of inversion of control. You can see here an example how to provide implementation of the inversion of control without dependency injection. In this case, there is no dependency injection pattern, but we are calling just a variable, and we don't know exactly what kind of method we are calling, because the method was selected in these lines here. So actually, it is a dynamic operation. Dynamic means that the list in the collection is dynamic. In any time, in any point in time, it could change. So there is no depend only on the design time. It also depends on the runtime. What happens in the runtime? Here we are adding, and here we are initiating, but the variable. But let's go to the. It is very important for us, but the event is also, because it's also very important, because it is it is also the delegate variable. So from the kind, it is the same kind of the usual as regular delegate variable. It behaves exactly the same. So we can assign to the event. We can assign we can assign methods. We are assigning reference to the method, and we can call of this method. The problem is what the event means in this case. What is the difference between this line and this line? Except of course, the identifier we are using. The difference is that in spite that the public is in front of this variable, we cannot call this method from outside of this class. So it is a limitation of the public access to all of the operation that we have for the delegate type. In delegate type, one of the operation is the method call. But for the event, this operation is hidden. It is limited only to inside of this delegate example. It is because in general, we are using events to communicate between objects. If one object are going to inform another object about something, about an new state of the object, can use the event and actually can call of the method that we have in this collection. It is very important for graphical user interface. A very important thing. One of the question we'll have. So now you can work on it, but I'm not going to ask it. Okay, let me ask this question. But make sure that we are on the same page. What operation must be supported by the view? You remember from the project classes that in the code, for example, there is presentation layer. Now let's think about the whole layer, and this layer is responsible to get connected with the user. The interface with the user we call graphical, because in any case we have graphics on the screen. Even here we can see the text, but at the end of the day the text is created from pixels, so we can enlarge or so we can modify the zoom of this picture. Therefore we can say that everything on the screen is just a graphical interface, even if it is used to represent just a text. Okay, so you are answering the question. To advise you, we have only three operations. That we expect as the interface between the user and the computer, the user interface. But yeah, because we are talking about the graphical data, it is very important to describe not only the data we are going to expose on the screen, the process data. Let me give you an example. Let's go back to, not back, but let's go forward rather. Let's get forward to the project that calls graphical data. Sorry, it is folder. Graphical data view, it is project that I'm going to start for now. It's program. It's executable, and we can start it. It takes a while, and the graphical user interface was opened on my second screen, so I have moved it here, and from the screen you can see that here we can, for example, clicking on this button, we can provide process data. It is the names or the years or checkboxes. So we can provide process data. We can expose the process data, but this process data is exposed in the context of a graphics. Here we have something like a window. Here we can see that we have buttons. There's another windows. Clicking on one item in this window, we can see that on the next windows we are getting additional details, additional information, additional data. Anyway, we need something to describe how the graphical user interface looks like. How many windows we have, how many buttons, where the buttons is located. We call everything metadata, because it's not the data we are going to provide the user, but it's very helpful to understand the data we are exposing in the context of the metadata. So the buttons, layering of this interface, location, all of the items on the screens, all of that we call metadata. So the question is how to describe this metadata. You know that there are many possibilities. One, it's uh, for remote access using the network. Sometimes we are using HTTP and HTML language to describe how the screen looks like. But in the applications that are dedicated for the local computer, for the computer, we can use we can use screen of the computer, and describing the layout of the screen. We can use, for example, it is just an example. We can use additional language. Let me open this file. It calls mine window. You are very familiar with this because in all of your code is something like that, because it's provided by the template. So we can see that the screen has two parts, and one part provides just a text. I can make it more readable. And on the second screen, we can see the picture. So we can see uh, um, uh, we can see how the system, how the environment, how the tool renders, displays this text on the screen as the graphics. So for us, for example, here it could be grids. That is something that we can see on the screen. Our buttons, we can find, for example, here, button. So it says, okay, display on the screen a button here in this place. So this description will also provide information about the place where the button is located on the screen, how to locate this button, because uh, it has a graphical representation. So the next question is related to this topic. You can probably know that. Let me close this design view. It is not for us important because we are a software developer. Therefore, we like to work with text, not with the graphics. But there are a lot of people that like to play with graphic, but don't understand the code. We should not expect from the people, from the user of our software, that are using the code, they are using this text. As you probably know, it is XML, expandable markup language. But we call also it XAML. Looking on the extension of the film of the file, you can see that we are using XAML. XAML means expandable application markup language. So the name is similar. The question was, what is in common between two? I am trying to read your answer. I can see that there are good answers. So let's go to this next question. If we know what is in common between XAML and XML, we can answer the question, what is the difference between XAML and XML? Yes, someone answered correctly that the XAML and XML use the same alphabet and the same syntax. In both cases, we have the same alphabet, so we are using the same characters, we are using the same characters, and additionally we are using the same rules how to couple together all the characters to make the text, to make sure that the text makes sense, that it's correct. But the question is, if the text that it's correct against the XML language is also correct against the XAML language, because in both cases we are talking about XAML, about language. Next, it's a very difficult question. I just in a second I will answer to the question, what is difference? Of course, the difference is semantics. It's semantics, so it's meaning. In terms of the XML language, here we have just element, and here we have just attributes. In terms of the XAML language, here we have something. We have an element that has graphical representation. So actually, we can improve the meaning. We can expand the meaning. It is not just a text. It is not just an element. It is something that has graphical representation on the screen. The same is, for example, with the window. Here we have the window. From the example on the screen, from the graphical user interface of my program, you can see that the interface is organized as a window, and the representation of this window, it's this identifier, and actually this identifier means that we are talking not only about the identifier, not only about an element, we are talking about graphical representation on the screen. So the question is, why XML is based on XML? XML. Why? What is the reason? What is the reason? Oh, you are trying to provide long answers, but the answer is very very, very easy. Let me do something like that. I'm right-clicking on this file, and you can see an option that is possible to open the same file in the program we call blend. So let's stop for now the discussion. I'm waiting as the blend establish all of this, all of the windows. It's huge program. You can see that now we can also see the text of the program. It's still working. So as an introduction, let me provide still. So we have similar interface as previously. We have similar view. So let's open just a designer. Let's open just a designer, and I'm going to enlarge it to make sure that everything is on the screen. We must remember about the user of the software, because usually it is the common point between the user of the software and the software developer. Graphical user interface, because the user interface is used by the software user, but it's created by the design by the software developer. Therefore, there must be possibility, there must be something, there must be a way that we can find the same terminology, we can say the same approach, scenarios. We can, for example, agree. I remember that a couple of years ago we have presented a program to some guys from US, and actually they are very happy with the software. They say that, oh, okay, it works pretty well, everything is what we expected, but there is only one problem, that the window, that the color of the window, that the background of the window is not American. There's something wrong with the color, because in US we are using different blue color. So the problem is how to make sure that the user of the software and the software developer can use the same background color. Of course, we can use, as you can see on the right side, we can use appropriate numbers. There are a few standards we are using to design the color, but typical user is not familiar with that. We must be familiar with that, but usually the user is not familiar. Therefore, after sending to our client, to our customer, a proposal of the graphical user interface, we are getting back the interface good, but at the end of the day, the discussion is about the colors. So there must be some way how to agree about the colors, and this is a solution. We can have additional tool, and we can give this tool and say, hey, you can select the color. After selecting the color, we can getting back modification. For example, here it is something that was added. Let me save the modification. Here we can see the modification. Let me save all and close this tool. In our software, we can see that there are some modification. So accept all of the modification. Let's go back to div produced by the GitHub. GitHub is very useful, for example, to follow all of the modification like this, that we are using many tools, we are using many software to work on the same text. So open containing folder, and in the containing folder we can find all of the modifications. Git, here it's all of modifications. Check for modification. You can see that this file has been modified. And from this modification, we can learn that actually it is something new added by this tool. It is a color, it's background color. So I think that it is very good. It is very good approach where we are using the text, but our customer clients using a tool that could be used not only to select the color, also to design the whole interface, all the details of this interface. Of course, we have no time to learn how to use this tool. It is tool embedded in the Visual Studio as the Visual Studio part. I'm not sure if all of the additions of the Visual Studio, but it is possible to get access to get license of this tool and use this tool by your customer, by your clients, to agree about the user interface. Okay, but let's go to answer why. For now, it is the question why we are using XML. Why the XAML is based on XML. The answer is from this example, because it is main idea to use the XAML, it is to use external tools, not users. It is not dedicated for the software developer. It was designed for external tools, but the XML, it is the perfect language we can use by any tool as the data. So actually, for this external tool, this text is just a data. It's just a data that we can edit using this tool and get back information, for example, about the background color. But as I said previously, the main difference between the XML and XAML, it is semantics, it's meaning. Because in XML it is just element, but in XAML, what it means in XAML? Let's go to the definition. Go to definition. From the definition, we can guess that it's a class. It represents the class. Actually, using the class in this place doesn't make sense, and the tool point out not only the class but also the constructor of this class. Therefore, we can assume, we can guess that here the meaning of this identifier, it is that we have a sign statement, and the expression of the assign statement, it is to call a constructor, and as the result we are creating an object of the grid. But to create the object of a grid, we must be sure that the reference is assigned to somewhere. As I said, it is assignment statement, but here we can see the variable we are assigning to. From now, it is difficult to guess. It is difficult to guess what happens with the reference to the new created object. We can only assume, we can only guess that this reference is assigned somewhere. Probably it must be related to the object in the site where we are using this statement as internal operation. Here, for example, we can see that the most top element is window. So let's go to the window. Go to the window, go to definition here. We can see that it is also class. But this class inherits from content control. So let's go to the definition. It's derived from control, but it also implements interface e added the children. From this, we can guess, seen on the definition of the, we can see that here is a method add children. So we can so it's possible that it's possible, actually it's true, that the whole user interface is organized like a tree. It's organized like a tree where we are creating this object, and after creating this object, the environment is using this method to add the reference to this object to the parent object. So here it is the parent object, and here is the child object. Next, we can see that the child object of the grid is list box, and so on. There we can, for example, can see that this grid contains text box. So it is a tree, but the root of the tree is here. It's window. It's most top object. This way we can navigate. We can know the structure. It is structured data, but we know the structure here. Knowing the structure, we can navigate. Being, for example, here in the button, we know the path to this object, provided that we have access to the parent variable or property. But it's up to environment, up to a framework that is responsible to do all of this operation. For us, it's very important, only important because of the possibility to provide a kind of separation between the layers. Now we are talking about the layers. We are start talking about the layers, and here we are dealing with description of screen, of content of the screen. Therefore, we can say that we are talking about selected technology. It is related to the technology. It must be related to operating system. It must be related to kind of computers. It is not universal. It is not portable. So it is part of the technology. Technology always is assigned to a physical devices, to the physical solution like operating system. Of course, we can make it portable. It is possible to use the same description on different kind of machines. For example, today we are using XAML as a language to describe user interface on mobile devices. So it's possible, but in all of the cases we are using different frameworks. Of course, some of the frameworks are portable, in spite that they are refers to concrete devices that could be used, could be applied to different platforms, to different devices. But still, it is related to technology. This description related to the technology. Therefore, we must answer two questions. First, how to make connected with the language we are using, because this is completely different language. If it's completely different language and this language is dedicated for the machines, therefore the question is how the C# developer could use it. What is the relation? It is part of our software, it's part of our program. From the right side, from the Solution Explorer, we can see that we can have two files that is related to each other. One file, this one on the screen, looks like C# program, and this one looks like XAML language. So the problem is, what is the relation between both? Between this XAML file and C# file. The only answer to this question could be done if it's really the part of our program. It must be translated. It must be translated to C#, or it must be translated to any common language. It is also possible to translate C# to another language, for example, to XAML, provided that the XAML is flexible enough to provide the same functionality. Because the idea of the XAML is to provide to be used only as a description of the user interface, as the graphical user interface, we cannot use XAML to provide any functionality. So we don't have statement in the XAML because it doesn't make any sense. But still, the interface must be dynamic. So it must react. Previously, I asked the question, what operation is expected from the user interface? Actually, we have three operations. First is to provide the process data on the screen in the context of the graphical data as the metadata. Second, it is to provide the data to the computer from the user of the program, entering new data. And third, it is execution of any commands, because we are pressing buttons. Let me execute once more this program to see all of this operation, to make sure that we are on the same page and we are talking about the same operation. Let's look on this graphical user interface. It needs a couple of seconds to run it. Now, you can see that previous my action to change the background of this screen is effective, because now we can see, I'm not sure if it's American blue, but still it's blue. It is the color we selected during the design time. But now we are at the runtime. During the design time, as I said previously, one of the action is to just to execute a command. After clicking of this button, it is just an event. It's something that happens. It is asynchronous event, because the software, it is impossible to expect it is impossible to by the software to make sure when the button is clicked. So the software must be prepared to handle the click on the button. Therefore, we are talking about the handlers, because it is good answer to the event. But still, we are not talking about the event variable. We are talking about the events. That meaning is in the natural language. After clicking of this screen, it is second operation. So the software provided process data. This tree, where I have the pen to make. I'm opening the pen, but where's my pen? Oh, pen is over here. So here we can see that we can call it process data. It is related to our business logic and to our data layers. It is a result of implementation of the algorithm. This button and the layout of the user interface is a result of designing. It is a result of the metadata. So this is data and this is metadata. And third one, it is to provide information to the computer. Let me here is a button. Click the button to display, not this one, click the button, this. Click the button to provide the text. Here, we can see the text is in this box, but this box, we can change this box. We can change the text in this box. I provide a random text, and now we can display this text. So it is two operation: entering the new text, exposing process data on the screen, and executing of the commands, user commands. And in all of the languages, in all of the cases, in all of the programs, we have only these three actions in context of the user interface. Doesn't matter if it's graphical interface or we call it just console application. In the console application, we are also talking about the text, because the text is on the screen, but still it's screen. Because it's screen, we can recognize pixels, and we can it is just a graphic. Okay, so first answer the first question, how it's related to the C sharp. It is related because it could be translated and could be edited as a part to the C sharp, because we have a construct we call partial class. Therefore, the XAML part we can recognize as the partial class. Of course, partial makes sense because partial result of the partial is merging of the text. Therefore, it makes sense only if the second part of the text we are merging is in the same language. If it's in different language, it doesn't make sense. Okay, so it is. I think that I have answered the question. What is the relation between C sharp and XAML, and why we are using XML as a foundation for XAML? Now answer the question how to make coupling between this technology and the rest of the program very easy to modify. Because if we are talking about the technology, always we are talking about possibility to change the technology. If we are using a software on a desktop computer, it's possible to use the same software on the mobile devices, but the technology is not the same. Therefore, the coupling must be very loose, it must be not tightly coupled. So the presentation on the screen and the rest of the software must be loosely coupled. Therefore, we need a general solution, and one of the solutions is MVVM pattern. MVVM pattern, it is, so let you ask you, where the MVVM pattern comes from? We are using MVVM, model view model. It is a pattern. We know that it is a pattern, but now the question is where it comes from. Where is the source of this technology? Where it is used? If it's possible to use it in different technologies. The answer is yes, we can use it in all of the technologies general pattern, but try to answer where it comes from. And in the same time, I'm trying to talk about coupling. Now you can see that we have custom class review main window that inherits from window. The window comes from presentation framework. Presentation framework, actually, it is responsible to provide appropriate classes that we can recognize as that has graphical representation of the screen. So using these classes, creating object of this classic and displaying this object on the screen, we can, at the end of the day, we can get a picture on the screen. So this must be related to the technology. But the question is how to integrate this part related to the technology with rest of the software, making sure that the coupling it's not hard, it's easy to replace. Let's go to the XAML. This methodology we call binding, and the process of binding, I try to describe this in a second how it works. But first, we must recognize something, that here we have strange names. We have strange lines, 3 lines. Let me replace these lines. I try to change this line, try to move these lines, because as I said, if it's not this one, C#. If it's it doesn't make sense in the C# language, but as I said previously, that the XAML is transferred, it's compiled to C#, therefore it must be compilable to the language. Let's try do something like that. Of course, this part doesn't make sense. Is it familiar for you? So let's check if we can run the program now. So it needs time, but now I can answer this question. Yes, we can run the software. As you can see here, we are getting the same user interface. Therefore, we can say that in XAML and in C#, we can translate this XAML to C#, and actually it means that we are assigning to data context. We are assigning reference to new object, and this new object is responsible, go to definition, it's responsible to provide functionality of the user interface. It is in different project. We can call it a ViewModel. ViewModel because it is responsible for behavior of the view. So previous text here we can call view because it's responsible how to organize the screen, how the screen looks like. It is responsible to provide graphical contents of the screen, but the main view model is responsible how it works, how to provide the data on the screen, how to display the data on the screen, how to read the data from the screen, from the keyboard, and how to execute all of the commands. It is very important because it is reference point for the XAML, for the binding. It is preview. It is not this class. Where is the window? Not this class here. So from this, I have removed part of this text and move it to the C#. Let me get back to the previous finding that all of the object created by XAML creates actually the tree. Here, well, let's see here on the button. As you know, button is a graphical representation of the physical button. So the only operation we can do on the button is just click on the button. Here we can provide as the parameters, as the properties, as previously, it is just a type. It's constructor, pick definition. It's constructor, I can see here without parameters. So we are creating an object. We are assigning reference to this object, to the pattern, the parent object. Here is this property. This property provides text on the screen, but here we can see bindings, property comments, and the word binding means that we try to bind the command and the fetch data comment. Go to definition. Can we use no? It is now. It's impossible to find. Now it's impossible to find where the fetch data comment is. The reason is because it is located in the object that is pointed by the data context. By data context is in data context now is assigned here. So let me remove modification here. Remove modification, undo. Now go to definition. Go to definition. Now we can see that it comes from the main view model. So the question is how to bind properties that we have in the view models in the next layer. Usually we are using the types in the layer above from the layer below, and to make sure that we have a layered application, it is wrong. It is an error if you are using the types in the layer below from the layers above. In this case, we cannot distinguish which layer is above and which layer is below. Here, it works like this, that in the runtime, after creating this object, we are trying to find reference to this property using the data context. Of course, during the design time, it works during the runtime, but during the design time, the tool is smart enough that if the tool knows this assignment, this statement, it can also distinguish the text where the property is located. So the question is what the binding is, what the binding means. The binding means that we are building something like something like a bridge between this property and this property. We have two properties. How to connect together properties? How many times this statement is executed during the runtime? It is executed only once during the instantiation of the object. Therefore, the binding must be responsible to provide to move the data from one property to another property at runtime, and it must be done only where the property has new value. If the command, for example, has the better example is, I think, it's text box here. So the binding should provide the name to the text property, and from the text property to the name property after all of the modification. Therefore, we must inform about modifications in the layer in the view and in the view model. What is the binding? After asking about definition, we can see that it's also the class. It's class. So here we are using the constructor of this type. We are creating new object, and this object during the runtime is responsible for moving the value from one property to another property during the runtime. But it is easy for the view to send data to the layer below after all of the modification on the screen. After modification on the screen, where it is this text bind current user is checked. text box. Here is a text box that we are using to provide new values on the screen, to modify the values. So it's easy to send using this binding to send the value from the text to the action text. But what happens in the opposite direction? What happens in, for example, the data layer that get access to the external database, try to modify this property. It must also inform the view. It must also inform the view that something happens in the layer below. So the communication must be in the both direction. Using of the types must be in only one direction, but communication and sending messages, sending information that something is new, something was modified, must be in the both direction. So let's go. Let's try to examine all the requirements we have. Let me ask you next question. Because still we are in front definition of the MVVM. Now we are talking about the general things, but now I'm asking what the MVVM, what it stands for, what it means. Probably you know, therefore it is very, very easy to get additional point. Next question we have answered. What types should be aggregated by view? Oh, it is too difficult question. What type should be aggregated by the view model? Okay, maybe it is good question because actually I have answered. Okay, let's stop the discussion because I hope it's very easy point. Let's ask you next question. What type should be aggregated by the view? Because as you know, view is a layer. Because it's layer, it is set of types. Therefore, we must know that this layer should aggregate all of the types that we need in this layer, only types that refers to the layer below, but we need to know a general rule how to select types that we have in the view. But now let's go back to examination about the communication between the layers. So go to definition here. You can see that it is property. It is very important for this language, but not only this language, that we are using properties, not only variables. Because in properties, we need to implement two methods. It is get method, we call it getter, and set method, we call it setter. In the set method, you can see these lines, these statements. So we can access what happens here. We are assigning new value. If user provides on the screen new value, we are assigning it. To this property, and for assigning this value, it is responsible binding, object binding, because it knows that something happens on the screen, and it could translate the text from the screen to this property. But if we modify this property here in this layer, not in the view layer, the problem is that the view layer must be aware about the modification. Here it's the most important, it's a property. Go to definition. We can see that this class, not this class, but the view, main view, not. I have not access. Let me open it once more. Main view model. It was here. Yes, let's pin it. We are inheriting from view model base. And view model base we have here. And from this, we are calling this method. This method calls the event. So we are getting back to the event term. Event, let me recall, event is a delegate variable. Therefore, using this method, we are calling all of the method that has been assigned to this variable. Next question for you. It is next very difficult question. What types should be aggregated by the view model? Just a few words. How to select types that we should use in the view model? Here we have events, and we are calling all of the method assigned to this variable. But the question is where this variable is assigned, because the only view is interested to know about all of the modification. If we are using this method to modify the view layer, to modify another class, to modify another object, because we are talking about the runtime, you are informing another object about modification. We must find a place where the handler is assigned to this property. Let's try to find all of this modification view, all references. Oh, there's a lot of references, but it is not assignment. Assignment we have here, but it is testing method. So we cannot find in the code any places where this variable is assigned. But we are calling this method. We are informing the view about all of the modification. Therefore, the problem is where the handler comes from and where it is assigned. Let's get back to this. Let's get back to this. To this XAML. We are creating object of the main view model. This object, this type, inherits from the view model base. And in the view model base, we have an event. Actually, we are implementing an interface view model base. We are implementing here iNotify property change interface. iNotify property change, make sure that we have this event. It provides only definition of this event. Go to definition, we can prove it, that here we have only definition of this event. Therefore, during creation of this object and assigning to the data context this property. So it also has setter. Therefore, during this execution of the setter, we can check if the main window model has implements iNotify property change. If it implements iNotify property change, it implements also the event. Therefore, it's a good time, it's a good place where to assign the handler. So you can see that we are not using reference from the type in the layer view model. What we are not using the types, but still this layer is assigning a value to this property. Okay, next question for you. It is, what mechanism is used by model view to modify the, oh, it is very long. Okay, let's skip this question. It's too long. Next, what type should be aggregated by the model? The next question is similar to previous. What types should be aggregated by the model? Now is good time to answer the question, what type should be aggregated by the view? Of course, we should aggregate all of the types that provides definition that are used to be to provide graphical representation on the screen, graphical metadata on the screen. Therefore, probably here we have no additional types, should not have additional types that are not used for this purpose. If we need any types that we are using for behavior of the screen, not just the layout of the screen, we should locate all of this functionality, all of these types in the view model, in the next layer, in the layer below. Therefore, we should avoid in this layer all of the modification, all of the types that don't refer directly graphical types that has graphical representation. Is this layer first. Second, they refer to only to the layer below, to the view model. And the most critical point, I saw that in some of your examples, you can put the code in the part that are coupled, the part that is coupled with the XAML file. It is not a good idea, because it is very difficult to test something, the code in the files. We call this part of the class as code behind. At least the C# code and the XAML code is coupled together. It must be coupled together, but we should avoid any functionality to be used, any functionality that is not necessary in the view. It is not dedicated only to the view. But here you can find that I have a method. Actually, it is I override the typical method that I can get from window. So let me explain why. What is the reason? But the last question for you, it is last message. It's very interesting for me, if you can answer to this question, because it is this answering to this question is related to the last message I have from these classes. What techniques we are using to manage streaming data, structure data, and graphical external data? What technology we are using? Today you learn one of them. But previously we discussed streaming, structural data, and also we discuss technologies we used in context of this type of data. Here, as I said, we can avoid any text that don't refers to the classes that has graphical representation. Here I am using dependency injection to make sure that view don't directly use classes that refers to the graphical. For example, here I have 3 window main view. It is graphical representation pop-up window, but I can it is impossible to create this. I am showing this window by executing a command in the layer below, but it is wrong to provide to create appropriate object in this layer, because it needs to refer in the layer below to types that are in the layer above. Okay, I think that's all. I hope that you will investigate this code in details. We have a few next lessons that we can use. We can spend these lessons to explain details. Now I don't have time. I must go to the finish of this lecture. Therefore, let me get back to my presentation. Where's my presentation? Presentation is over, not here. Oh, here. Okay. I must stop the discussion. Because the answer to the last question is here. Here. Stop the discussion. So at the very beginning, we discussed streams data, actually files. We use serialization and deserialization. It is two technology we are using to manage streaming data. Talking about the structural data and databases, we are using language integrated query, LINQ, and object relational mapping. These two technology are used to manage the data that are provided by external data sources, by the databases. And graphical data, XAML is a technology. Actually, XAML, the name of the XAML, the context of the XAML and MVVM comes from Microsoft Windows Presentation Foundation. When the Windows, as the name says, the Windows Presentation Foundation is dedicated for designing of the user interface. Therefore, XAML and the MVVM are related only, should be used only in the presentation layer. So we have these four techniques we learned, and all of them are related to the appropriate type of the data. So I think that's all for today, and that's all for this classes, for lectures. That's all I can do for you. So let's switch the recording.